Hello for all. This is my presentation. My presentation today about observations of measures. Yesterday, Edward Moll told well about nature of measure emission. Now I will tell about major emission in methanol, lane 6.7 gigahertz. Uh, this also emission from star forming regions. W75N is specified in my title, but this is not only but this star forming regions belongs to larger star formation complex, sinus X. You can see well colored photo of this complex here. This is infrared picture, infrared colored picture from Spitzer camera. This is W75N has very close companion, DR21 in these regions. They are really very close. Coordinates is specified here, and the DR21 is even brighter in infrared. Even brighter in infrared. They are very close and cannot be distinguishable by small dishes we used as the meters for observations. Star forming regions usually have relatively high infrared luminosity. Methanol measures I observed belongs to class 2, is pumped by infrared radiations mainly, and works as a tracer of processes in this forming region. Also in W75N and around, many of water and hydroxyl tracers were observed. Also, I should again, I also should tell again that mother lines are very interesting by their variability and changes in matter spectra. Here is pictures from locations W75N and DR21 locations in different wavelengths. Short infrared is here on the left, and far long infrared and far infrared spots are here. Is even millimeter wave spots. You can see DR21 is elongated in its spot. Sometimes its coordinates is specified at the bottom. Here in my pictures, the center of picture is correspond to coordinates of far infrared and uh, measures emissions. Methanol measures emission. Uh, Next. Here is more infrared pictures about these two regions, GR21 and W75N. Uh, Distance to them is about 2 kiloparsecs. Uh, many H2 ionized hydrogen spots were detected in both regions. Also, O and B spectral type stars were observed there. W75N far infrared luminosity uh, is up to this value. GR21 is really brighter, almost 2 times. Uh, mm, uh, but I can tell you a bit later. You can see detailed picture of these regions. As you can see, uh, far infrared spots is concentrated in top parts of DR21, and W75N is more simple in the structure. DR21 is brighter in far infrared luminosity, almost 2 times, but its methanol methanol radiations, mainly in masers, is significantly lower than W75N. Peaks of DR21 about 10 Jansky and peaks W75N about 200 Jansky. Both regions have rich spectrums. As I told, DR21 is significantly weaker, and there is no noticeable methanol radiations observed in other parts of Cygnus X. This data is taken from Japanese database observations instrument a single dish 32 meters. Next interesting map of W75N. This is most, as I expect, this is most prominent source of methanol radiation in Cygnus X. You can see blue triangles is water measures, circles is methanol, points of methanol measures detected, and also contours show 1.3 centimeters continuum radiations from these regions. You can see this marked as VLA1, VLA2. This the names of spots, as you guess, continuum observations were made in VLA facilities. Step of contour, step of contours about this value in milliansky nabim or in milliansky per beam. Maximum is about 1 milliansky nabim per beam. And it corresponds to maximum temperature in this protostellar cloud is about 300 kelvins. This is almost room temperature. Is this temperature far from hydrogen ignition? But this shows real picture in star forming region where the future protostars and stars is expected. About my observational instrumentation. This is a small single dish, 2.4 meters. This dish was designed here in Moscow by our local millimeter wave man, Radio Whiskey Sribar Bravo Papa, Sergei Zhutev, and optimized it up to 1.134 gigahertz. This you will azimuth elevations rotational system for this dish. You can see feed for this dish is installed for 6.7 gigahertz. Beam width of the dish is about 1.3 degrees and 6.7 gigahertz. This is rather wide beam. This dish cannot distinguish W75N and R21, and also may receive radiation from all signals X. Fit with linear polarizations and all observations with automatic tracking of observed source locations, all the integration time. Shortly about estimations of telescope parameters. Here is the aperture efficiency of this dish. I expected is somewhat larger, about 0.7, but this value was obtained by observation by slow observation of sun, by measurement of solar radiation, and because of solar size is about beam size, and they're comparable. So this fact should be taken into account when we calculate any data from when we extracting the data from solar measurements, because beam of this dish can see the sun not as point in the tip of the beam, but sun is somewhat wider than tip of the beam. Most important characteristic of observation system is system requiring flux density. It's most important for measure observation. Flow from solar measurements is this SUD can be extracted immediately without without measurement of system temperature, but I have measured the system temperature. Also, it's about 100 kelvins. Minimal detectable peak flux density is about 80 Yansky for resolution 7 receiver resolution 5 kilohertz and integrations about 1 hour. This value of minimum detectable peak flux density can be obtained from radiometer activation, especially routed for measure line, lines. As you can see, classic radiometer activations with system temperature can be can the system temperature should be replaced by this analog in flux density units by system qualified flux density frequency bandwidth now becomes receiver resolution bandwidth. Integration time is changing also because we need to get peak value from measure line noise peak factor, background noise peak factor about three in value should be inserted in regular equations for measure line. These equations describe situation when measure peak is on the same level as background noise peaks. So this equation can estimate that the telescopic performance, as I can see, about for my system, it is about 80 Yansky. And results of observations, my observations from November 2024 until beginning of February this year. You can see beginning of November the observer spectrum is really close to expected. I can show you expected from Ibaraki limit. You can see this form of spectrum is expected and even levels almost the same as expected. Max about 200 Yansky. Main line about 4.5 kilometer per second and normal line about 7.5 kilometer per second, and DR21 for For my observations, this threshold about 80 Yansky is expected under threshold of detections. So my observations, the spectra can show only W75N. But in the second half of November, spectra already changed. The main line for 4.5 kilometers per second is almost unchanged, but 7.5 kilometers per second line disappeared. I, I, I didn't find any hints for presence of this line in post-processing procedures. So some line is about 9-10 kilometers per second is appeared on the spectrum. Similar line, but very weak, is observed by MET instruments, but very weak for usual quiet state. Next observations is December, line about 7.5 kilometers per second begin to restore. And addition group of line about 10 kilometers per second is fading. Is fading for in December. Next observations December, January spectrum still narrow 7.5 kilometers per second line is observed. Main line become narrow. This lines on spectrum can be radio interference. Can be from radio interference. This very unexpected here, but I suppose this is not physical. This is not from any source from the sky. This is not from any source from the sky. Next spectra, narrow sample 7.5 kilometers per second line, narrower 4.5 kilometers per second line, and final spectra with some perturbations about 10, about 9-10 kilometers per second. Line 4.5 kilometer, line 4.5 still steadfast for in this in 2-3 months from beginning of November, but became narrow. A few words about my post-processing procedures. That I should remind the detection threshold is about 18 Yansky for used resolution bandwidth and integration time. So receive signals are a bit over the noise peaks. and line extraction in procedures based on expected line velocities. Uh, they give useful tips what bumps or noise flow can correspond to the major line. For show spectrum, the noise outside major line is noise outside the major line is reduced. Uh, this is made for a better view of spectra. So some unexpected line some unexpected line in the spectra may appear as artifact of post-processing. I do not exclude this in these observations. Nevertheless, observing of major line and hunting for their variability is possible even for small dish when peaks of observed lines is a bit higher than uh, minimal detectable peak flow density. Threshold of detections. Threshold of detections. As I told, obtaining of result is guided by expectations in line with velocities. Variability of 6.7 gigahertz laser in W75N can be well seen even with small dish. Very steadfast line, 6.4 kilometer per second remains with minimal change, with little changes, with become narrow, and disappearing inflation, 7 kilometer per second line. So well, it can be well noted. Other lines may appear as post-processing artifacts and can be not and can be not correspond to real events and events in this star forming region. I do not expect these changes and this variability are from year 21 flares and just a small probability of observed flares can be stem from other part in this big star forming complex sinus X. This is all for now. Certainly my acknowledgements for Sergey Redivist, Bravo Papa, for well working dish and well working tracking system and help in observations. If some questions, I will glad to answer.